Good morning, everyone. My name is Geoff Huston. I'm with AP-NIC. I'm the Chief Scientist there. Look, I'm so sorry I'm actually not with you today. It seems that me and my bike last weekend parted company, which would normally be fine, but I didn't just get off a stationary bike. I was ejected from a bike travelling at some speed, and the resultant bumping and grinding and so on caused some degree of damage to my poor body. And when I said to the doctor, I'm thinking of travelling, next week, he goes, you're joking. So here I am, and there you are. And the good news is I'm feeling a little bit better every day. I am healing. Unfortunately, I'm not here to give this talk in person. So you're going to have to put up with virtual me. But hopefully the topic is kind of interesting and provocative in some ways and gets you thinking about some of these issues. So let's look at it. I've been doing a lot of work in measurement over the years. And part of the reason is because nothing seems to happen the way we thought. Some of these things, and you think a lot of the areas of security would be a no-brainer. Surely a trustable and trusted communications infrastructure is better than not. Security is one of the things we rely upon in terms of interactions at a distance where there's no other mechanism to understand about authenticity. And even today, when the internet is plagued by all forms of quite horrible forms of abuse and fraud and crime, it somehow, the basic elements of security seem to be resistant. I'm like, why has it taken almost 30 years for DNSSEC to have got nowhere? 10% of domain names assigned. 30 years for just 1/3 of users to do validation. That's a huge amount of time. You kind of think, well, if it's taken that long to get that far, how long was it going to take for a useful level of deployment that actually means you can count on the DNS and rely on the authenticity of the answers you get from it? And it's going, geez, that's a hard question. Really hard. What about routing security? Well, it's looking much the same. This is a long saga of effort, from around 30 odd years of effort to try and figure out the right framework for doing routing security and then getting it deployed. Yet we're still a long, long way away from saying this is good. So when you launch a packet out there onto the network with an IP address, how do you know it gets to the right destination? The answer is you don't. Surely that's not right. Surely we should be doing more about this. Now, what's failing us? Is it that you and I are lousy at our job and we should retire and go and do something else? Or is there something else out there that, despite our efforts, getting common adoption of infrastructure is just being resisted? And I suspect that the real answer is yes, these are instances of market failure, because no one's in charge in the internet. No one's telling us what we do. It's all a case of responding, each of us individually, to the pressures we see of a common marketplace, that everyone's actually trying to optimize themselves and supply goods and services at a price that consumers want. And somehow the signals in that market are sometimes perverted, and what you would think is common interest actually doesn't work, that folk don't understand or don't get that signal. So is this area where security is just failing to gain traction in the market an instance of market failure? Well, the obvious answer is, yeah, of course it is, by definition. Let's all go on to the next talk. Oops. But no, not so fast, not so fast. Perhaps we could sort of flesh out this concept a little bit and try and understand why we have to push so hard to get folk to do routing security, to get folk to do DNSSEC. Even V6 is kind of the effort of this massive multi-decade push. Why does it need a push? Surely it should just happen. So let's talk about some terms, what are the implications, and maybe a few thoughts about how we could improve that picture. What do I mean by infrastructure? In my case, what I'm talking about is the infrastructure of our common framework that defines the internet on names, addressing, and routing. And security is really all about the uniqueness and the authenticity of use. That this is my address, it's not yours. and you can check the authenticity of my association with that address. Similarly with routing and names. So we're talking about the integrity of those realms, and security is about how to protect that. What's market failure? Well, Investopedia says it's inefficiencies, that individual incentives for what it calls rational behavior don't lead to outcomes for everyone, which is kind of what I'm saying. And a public good, well, like air. It's non-excludable. My use of it doesn't stop you using it, and non-rivalrous. I can't use all of it, and neither can you. We can all use it together. It's a public good. So what's the issue? Well, there's no one in charge of the internet, as I said. It's largely a deregulated environment, totally dominated by market pressures and a certain amount of regulatory bleating down in the edges. But nevertheless, in general, there's no forcing functions to ensure that everyone adopts a particular mechanism or technology. And so when we talk about security, no one's forcing you to do DNSSEC. It's your call. Whether you sign your domain name, your call. Whether you generate route origination attestations and so on, your call. And in essence, the common adoption of these things is actually not because everyone was being told, you must do this. It's because we all see some perception of individual benefit in doing it individually, creating a collective common good that everyone does it. Market forces, not regulatory impost. The problem is that that kind of picture sort of assumes some degree of homogeneity within the market, that when there is a perception of pressure, everyone reacts to that pressure, indeed perceives it, reacts to it in a similar way. If we see it differently, then that's much harder to sustain. If only a few folk perceive that the benefit is worth the cost, then only a few folk are going to do it. And a lot of the markets in the internet do tend to be heterogeneous. They tend to differ in their perceptions. Why hasn't everyone done V6? Well, the answer is in some ways, there's a different perception of cost and benefit in adoption across the internet. And that leads to variance in outcomes because of those different individual perceptions. And so what actually happens here is there's no clear, immediate, and common judgment of the benefit of doing anything. The internet is not a vastly uniform place. It's actually a place that has a fair amount of common perceptions of difference. So the next part of this is there's lots of moving parts in a network. There's the upper level of service and content. There's the level of infrastructure in terms of hosts, applications, and services. And then at the lower levels, there's kind of the ISP, and there's moving packets around, whether it's access or transit, CDNs or whatever. Now, they all see the world through very, very different lenses. And if you look at the ISP level and go, well, if I do RPKI, route origination validation, I have improved the picture for my customers, surely. Can I charge them more? No, they'll just go to someone else who charges less. And similarly, if you're a DNS hosting provider, could I charge more for DNSSEC? In general, when folk have tried that, the answer is customers don't adopt it. They say no, or they go somewhere else. In .SE, the experience was the only way DNSSEC actually got large amounts of uptake was by a discount, by actually creating a reduced cost to create that incentive. So it's very hard to monetize investments in security individually, and that becomes the disincentive. We see this in the data when we look at the proportion of routing objects that are not covered by a ROA. 80% a few years back, it's still at 50% in V4. This stuff is going very, very, very slowly. How long is it going to take? I don't know, but it is some time. And the net result, across some 4 years of looking at this, looking at the proportion of users who cannot get to a destination if it's invalid in terms of route origination validation. Invalid. It's been about 20% now for some years. We're just not making headway in that particular area of security. So all of that effort with ROAs and sign things and do the right stuff isn't actually making much traction on the larger problem. We're not making progress here. Even with DNSSEC, the amount of validation, if you look at the inverse, the proportion of users who will accept a badly signed answer, 90% 10 years ago, no one validated. Even today, 70% of users will happily go to somewhere if it's badly signed. Don't care. Because the recursive resolver infrastructure they're using doesn't care. So the picture isn't good. And even if you look at what we do inside the regional internet registries, do we sign our registry? Do we actually say, here's the answer, and here's why you can trust it? Here's the authenticity of that answer in terms of a digital signature. None of us do. Oh, it's too hard, and the perception of benefit is so low, it doesn't outweigh the incremental cost of doing it. We take the easy way out. Now, what does this mean if I'm designing an application? The lack of infrastructure security everywhere. The picture is, I do a DNS query as an application, I can't trust the answer. When I generate a packet and send it somewhere, I don't know if the packet reached the intended destination. I can't trust the answer, a priori. The fact that you sent a packet to somewhere doesn't mean that the answer is good. These are problems for the application. And the safest course with partial adoption is to assume that there is no adoption. If it's only partially there, you don't know which parts are secured and which parts aren't. So the only way is to get through it is to assume that none of it is secured. None of it's reliable, because there's no way you can do it any other way, yes? You just can't count on universal availability. And so what do you have to do? You have to do it yourself. You have to make sure that the application itself is in making its own efforts to ensure the validity of the destination, whatever you're trying to do, and do that without relying on infrastructure. It's most visible in the uptake of TLS at the web level. This is a Cloudflare radar report looking at the availability, the use of HTTPS in the web from Cloudflare's perspective. That's not 30%, it's not 70%, 97%. And it happened without a massive effort. So the application is sitting there going, got to do it, just got to do it. A little bit of prompting from the browsers, and all of a sudden TLS is ubiquitous. Application level solutions are getting a far better benefit of deployment than infrastructure. So when an application is using TLS, which they do these days, what value do they place on infrastructure security? When I'm already using TLS, does DNSSEC add anything to the picture? No. How about RPKI? Well, I don't care which address I got to. If it can prove its authenticity via TLS, I'll trust the answer no matter what. So what's the value of RPKI? No. So applications don't value infrastructure level security, particularly when they're only partially adopted, because they can't rely on them. I think it's part of a bigger picture. What we're actually seeing on the internet is actually a shift upwards of value. In the 1990s, when things were, if you will, scarce, the network was actually rationing the scarce resource of comms, that you couldn't afford to replicate your content on servers all over the planet. You placed them at one point on the network and then used the network to bring users to you because you couldn't afford to replicate. Then that created a value proposition where the network was the arbiter, the rationer of the scarce resource, and actually all the value of investment was inside moving things around inside the network. The value transformers moved up the stack. The inexorable pressure from Moore's law, cheaper computing, cheaper processing, cheaper storage, and oddly enough, the use of more capable digital signal processing has actually created cheaper comms. We're now talking about terabit fiber for the same fiber cost as what used to be hundreds of megabits of fiber. That all of a sudden, we're now seeing a world of abundance down in the network layers, down in the infrastructure levels, complete abundance, which has actually pushed down their value and turned them into commodities. And the true value these days for users is up at the upper levels of the protocol stack. And so now applications are taking on many of the roles that we thought in the 90s should have been done at the common infrastructure level. The applications are going, well, I've got all the money. I don't need a common infrastructure solution. I'll just build my own. And so the lower layers are commoditized and stripped of intrinsic value. And oddly enough, that's actually created a weird relationship vertically within the stack, that all of a sudden hosts and networks have some level of distrust with applications. And so what we're finding, for example, in the Apple ecosystem, Apple produces Apple Private Relay, a system that completely obscures everything the device is doing in terms of application behavior, obscures that from all of the lower layers of the network. They can see nothing. And so what we're now seeing is applications kind of using techniques such as quick and mask, and indeed TLS, to wrap up their service interaction, to wrap up their activities that actually further increase this distrust and suspicion. No one can see what's going on across elements of the stack. And what that means is that if I don't trust the network, then if it does these routing security, DNSSEC, and so on, if I don't trust the infrastructure, I place no value on whether it does infrastructure security or not. And if I place no value on it, I'm not going to fund it. And that leaves the open question, well, who's going to be left to fund it? If I believe as an application that the network is untrustable, then really hard to then say, well, I've done some measures to make my part of the network trustable. Please pay me. The answer is, well, sorry, no. So when you say, well, what about more money into DNSSEC? ICANN, I think at the moment, is saying, well, let's do more push into DNSSEC. And the real issue is, well, who's going to pay for it? Where would the funding be directed, even if you could find some money? And who would actually make use of that? And the real issue is, even if such infrastructure funding might exist, it's very hard to identify where and why you would place effort when applications, the service level, is kind of going, nah, I'm just going to assume it doesn't work properly and have my own mechanism to actually ensure the authenticity of the service of the application. And a similar kind of picture exists with BGP and routing. Exactly the same set of questions that, why does anyone care anymore? And the answer is, well, they don't. And because of that, we're providing our own solutions. The solution from the content distribution network is actually to not route. Once you've deployed a CDN with a few thousand points of presence, then every single access network is adjacent to one of your points of presence. There's no routing anymore. And so when you say of a very large CDN, what's the value you place in routing security? The answer is, I care more about the authenticity of the advertisements I see from my directly attached clients, but I really don't care about the rest of it. I don't care about the security of the routing system because I don't route. I don't move traffic through large amounts of third-party networks. It's me and the adjacent access network all the time. And so infrastructure tends to be marginalized, and quite frankly, there's underinvestment because there's no point. Now, I've painted a pretty extreme picture here. Maybe there's another way of looking at this, and that is, can applications do it better? How can we improve the assurance of the authenticity of the services? And certainly there are weak points. TLS has its problems, glaring problems. Can we use something else to actually pin down TLS? Because that whole network of third-party certificate authorities has caused us trouble in the past and will no doubt cause us trouble in the future. Are there other approaches that make things better? Well, interesting. Because you see, we're constantly evolving on the internet. And partly this is the inexorable pressure of Moore's law, that computing, processing, storage is getting ever cheaper per unit. And what that means is we're actually making a network structure that is more capable at the application level. We no longer have to do one thing at the bottom and have everyone trust it. Common infrastructure security mechanisms reflect, I think, a picture of networking that's a few decades old. And quite frankly, the technology shift is to lift everything up and actually allow endpoints and applications and services solve the problems directly. When we think of security as being an ISP problem, a market failure at the bottom level, and it requires regulation, then maybe that creates regressive imposts. These aren't helpful anymore. So when the FCC proudly pronounces a few months ago, May in 2024, we're going to start looking at infrastructure routing security, maybe that's a picture that's a few decades old. Maybe that's just living in a past that isn't relevant anymore. We don't do it at that level. Applications are now capable enough and have enough resources through abundant computing and processing and storage that it's being solved at a different level. And it's kind of always beware of regressive imposts that reflect a past that the market's long since moved past, that the realities of the economics of networking have moved on. So what should we do? Persist? Well, we've been doing it for 30 years. It's now become a habit. Let's keep on doing it. What do we need to do to make every domain DNSSEC signed? What do we need to make everyone doing ROAs? What do we need to do to get everything happening where it's been failing for the past 30 years? And I think pressing on is almost like anti-gravity. It's kind of pushing deeper and harder into something that's structurally flawed, that doesn't reflect the realities of the situation in which we live. Because realistically now, the money, the control of quality, the control of authenticity, the control of the user experience has moved up the stack into the application space. How can we help these application transactions create the necessary assurance to give to users of the authenticity and value of their transactions? How do we create that level of assurance without asking the infrastructure to go and do things it's been failing to do for decades already? I'll leave you with that challenge. I actually don't know what the answer is, but nevertheless, I think it's the question of our time. If we can answer that question, I think we'd find ourselves working in a more harmonious relationship with the true economics of the internet itself.